Huh? Because I haven't plugged in the thing yet. There we go. Thank you. All right, my friends, 4.1c, if you've not already done it, we're going to take a look at it together. This is for quiz 3. You know what? Let me take that one and put it elsewhere. Okay, so quiz number 3 is essentially like quiz number 2 and quiz number 1, but put together. So you need to still memorize your prefixes. So if you've forgotten them over the weekend, it would be a good chance to remind yourself, especially the ones that people tend to forget, like tetra and hepta, and occasionally hexa, although I feel like people do that one better. Just remember, hex and 6 both have X in them, right? Now, you will need to recognize whether a compound is ionic or molecular, which also could be called covalent. There is a, I would like to say typo, it's just an error. It said that ionic was metal plus metal. That is obviously not correct. Ionic is metal plus non-metal. It is going to begin with a metal, or later on we'll learn that it could also begin with NH4. We won't see any NH4s yet though. Molecular is non-metal plus non-metal, but it also includes the metalloids. Metalloids behave like non-metals when they are bonding. So if that is the case, if a metalloid behaves like a non-metal, what kind of compound do we get if we put metalloid with metalloid? Molecular. What do we get if we put a metalloid with a non-metal? Molecular. And what do we get if we put a metal with a metalloid? Ionic. Okay, and then there's just a little picture here reminding you where the metals, non-metals, and metalloids are. And once you've done that, it is just a matter of remembering that ionic compounds do not use the prefix, but molecular compounds do. And then the only other thing is remembering all those little things you had to remember for quiz number 2. Like there's no mono on the first word, but there is mono on the second word. All other prefixes are on both words. And you drop the O and the A only before oxygen and oxide. For both ionic and molecular or covalent, the ending of the second word changes to "ide," but the ending of the first word does not change. I don't want to see sodium chloride or diphosphide monofluoride. The ending of that first word should not change. Okay, so you can, on the quiz for this one, you won't have to let me know whether it's molecular or ionic. I'm just having you do that in order to review for yourself. Okay, so before we carry on though, I actually would like to take a look at 4.1D as well, so that you can at least take that home with you, even if you don't get to quiz 4 today. So this is on page 20. Page 20. Group 1 metals, the alkali metals, what is their charge when they form an ion? Group 1 forms ions with a +1 charge. Group 2 forms ions with a +2 charge. These metals are referred to as being monovalent. What does mono mean? One. Valent essentially has to do with the valence electrons. It has to do with the charge, meaning they have only one possible charge. Sodium is always just +1. You cannot have sodium which is 2+. It doesn't exist. Calcium, which is in group 2, is always 2+. You can't have, say, calcium +1. It does not exist. However, not however yet, the other monovalent metals are group 3. Group 3 are all 3+. And then we have our little, do you remember that little miniature staircase in the middle? We'll pull up our periodic table here and take a look at it. Those are also monovalent. So if we look, actually, maybe it's right here. Oh yeah, it is right here. Look at that. Now, I think this was for my grade 9s. I actually had them color in. I call it the red zone, although because we cannot photocopy and color, yours will be the dark gray zone, okay? The gray zone is all of the, what do we call these metals in the middle? These are the transition metals. All of the, what are these guys down at the bottom called? Lanthanides and actinides. And then we have some of the other metals, right? Our other metals are just in here, okay? But do you notice that that column, even though those are transition metals, they are not part of the gray zone? Yes? That's because group 3 is 3+ only. Just like column 1 is 1+ only, column 2 is 2+ only, column 3 is 3+ only. The other monovalent things, the things that don't have more than one charge, are in this little staircase in here. And these ones are, the group of 3 of them are all 3+, the group of 2 of them are all 2+, and that is 1+, okay? Anything that is not in the dark gray zone does not use a Roman numeral. Okay, so the dark gray zone use a Roman numeral. If it's not in the dark gray zone, do not use a Roman numeral. I'll just call it the gray zone. And the reason that we use a Roman numeral is because, say for example, for iron, iron can be 2+, and that's okay. But iron could also be 3+, and that's okay. So if I just write iron, you're like, oh, well, what's the charge of iron? I just don't know, right? I would have to specify for you. So it's iron 2 or iron 3. What does the Roman numeral tell you? It tells you the charge, not the number of atoms. Do be careful with that. I often get people, they see the 3 and they're like, Fe3. No. That's not good. Okay, it tells you the charge. So metals in the red zone or the gray zone require a Roman numeral. That was why I liked red, because R for red, R for Roman numeral, but of course, I can't make red photocopies. So sad. But what we have then is we have iron 2 is 2+, and iron 3 is 3+. And here is how you find the Roman numeral. You write out all the ions, the correct number of each. You find those from the subscripts. You will look up the charge of the negative ion. Because if you remember, if we go back here, where did it go? Nope, not there, this one. If we go back here, is there any question of what the charge of fluorine is? Or do we know the charge of fluorine? We know it. Fluorine is -1. So we can always know exactly what our negative charge is. We can know that nitrogen is -3. We can know that oxygen is -2. And say, for example, if we had, something O2, we would know that there were 2 oxygens, each with a -2 charge. So we would have a total charge of -4. Okay. Don't worry if that went by too quickly. We're going to actually go into a little more detail right now. Nope, not that one, this one. Okay. So we're going to look up the charge of the negative ion just by looking at our periodic table. We're going to find the total negative charge. Remind me, what is the overall charge of a compound? Always 0. Compounds are always 0. So if the total positive charge is +6, that means the total negative charge must be +6, so that they equal each other out and they come out to 0. If the total negative charge is +2, then the total positive charge has to be +2. Anyway, the numbers have to be the same for the positive and negative charge. And then you basically just split up the positive charge amongst all the cations, and there you go. So step number 1, we have Fe2O3. Fe2O3. I'm actually going to do it off to the side. Fe2O3. Can you do this without this process? Yes, you can. If you find it easy, go for it. If you don't, write it out. Yes? How many irons are in this formula? 2. Fe, Fe. How many oxygens are in this formula? 3. 1, 2, 3. Then we say, what is the charge of O? What's the charge of O? Nathan, what's the charge of O? Yeah, what's the charge of O? -2. So we're going to say, okay, we got 2 minus 2 minus 2 minus. So what is the overall negative charge, the total negative? -6. So the total positive has to be +6. And so what is the charge of each iron? 3 plus. And it is the charge of a single iron that is your Roman numeral. Is good? So this would then be iron, and our Roman numeral would be 1, 2, 3, oxide. So many people look at this question and they see this 2 here, and what do they write, do you think? They write iron 2 oxide, but that is wrong. You only do that if you see the charge. Okay? So our next one, what have we got? Cu3N2. Cu3N2. Would we like to name this copper 3 nitride? Do we like that? No, no, that would be wrong. We have 3 coppers, Cu, Cu, Cu. We have 2 nitrogens, N and N. After you know how many of each ion, what's the next thing you do? You look up the charge of who? Of nitrogen. What is the charge of nitrogen? 3 minus, and so we say we've got 1 3 minus, and we have a second 3 minus. That gives us a total of 6 minus. If I want my overall charge to equal 0, what does the positive charge have to be? It also has to be 6. Now I have 3 copper ions all adding up to give me 6. What is the charge of each one? 2 plus. See how we split up the 6 plus 3 into 3 places? So that tells me that charge there, that is my Roman numeral. So this would be copper 2 nitride. There's a shortcut way to do this. Do you want to see the shortcut? It could lead to you making mistakes. Do you want to see the shortcut? Okay. And I'm going to show you one example where it works beautifully and one example where it could give you problems. Okay? It could cause you problems. Yeah, it is a gamble, exactly. Mn2O7. You can, if you want to, take this number and move it up onto the O as the charge. Ooh, look at that. So O is 2 minus. You can take the 7 and move it up. We're basically crisscrossing here, yes? So we're crisscrossing those numbers. And so now we have the Mn, And the number we're going to put up top as the charge is a 7 plus. And so this would then be our Roman numeral. Okay, and then our formula or our name would be manganese. Do you guys know how to do a number 7 in Roman numerals? Yes, it's 5 plus 2 essentially. V is 5 and then another 2. Manganese 7 oxide. Now, here's where it could go wrong for you. PbO2. Okay. We're going to take our 2 and the one that's not here, and we're going to crisscross them up so they become the charges. So the Pb, this 2 is moving up onto the Pb, so that's Pb 2 plus. And sometimes people get excited and they stop here, and that's where you could make a mistake, because watch what happens. If we take this nothing that is a 1 and move it up onto the oxygen, what's wrong with this picture? Well, it would be equal to 0 because I have two oxygens, right? That would be equal to 0, but there's still something really, really, really wrong with this. Oxygen's charge is not -1, right? So if you were to write lead 2 oxide, you would get this wrong. What you would need to do is, if you use this method, you need to check that that is the correct charge. If it is not, you would need to say, well, it should be times 2, which is O2 minus, which means that this one also has to be multiplied by 2, so that would be Pb 4 plus. So that's the risk you take if you do the shortcut. Yes? On the other hand, if you do it this way, and many people get so they can just do that in their head without, like, you know, writing it all out, and it can be just as fast or faster than this crisscrossy business. You can actually get really good at it. It's basically just playing with lowest common multiples. Does that make sense? Lowest common multiples? Yeah. Yeah, you can just stick with the regular strategy and it's good. So I think that's all I would like to cover for today. So you have, if you've not done quiz B, make sure you, or quiz 2, make sure you've done quiz 2 before you leave today. If you're feeling ready for quiz 3, you can do quiz 3. If not, 3 and 4 will happen next day, okay? You can also do quiz 4 today if you want to, if you're feeling, yes. Okay. Yay! Thank you. I changed them to the most bestest. That I just did say most bestest, didn't I? That, yeah.
I finished this right before.
That was your most bestest. Hang on 1 second, sorry.
I finished this right before I started talking about like 4.C. So.
Oh, so good. Oh, so good. Erin, which quiz was that? 2? Perfect. Okay, so I'll let you ponder what's wrong with those comments so you can figure it out, okay? Yes.
Didn't it say that not metalloids acted similar to elements?
Uh-huh. Which metalloid are you thinking of?
metalloids down the stairs.
Yeah.
Isn't aluminum kind of metal?
No, it's actually a metal. Aluminum's a metal. Yeah.
Okay.
Sorry, what? Yeah. The only thing that's different here is we're putting them together, so you have to recognize, do I use the prefixes or do I not use the prefixes? Yep. Yep. There's nothing new in quiz 3. It's just quiz 1 and 2 together so that you can know when to use prefixes and when not to. And also, John, it would be hydride, not hydroxide. Yeah? Yes.
It's because this is a noble gas, right?
No, it's because that prefix is nona, not neca. Yep. Don't you have you gotten your polyatomic ion chart? Yeah? Your polyatomic ion chart? Yes? Yes? No? And I have extras of there's extras of those on the counter if you want them. Geo. Hydroxide is a polyatomic ion. Hydride is the H ion. Yep. Oh, wow. No, it's not actually. You may have just got yourself a pen. Ooh. Sienna. Yes. Okay. Hydroxide is OH minus.
Oh.
You're not the only one. There's a reason I put it on here.
It's just hydro.
Yeah. But other than that, you're good.
I'm still doing it.
Yeah, of course. Sure. Why not? So mono has to go on the second word. We don't put it on the first one, but we do on the second one. Okay. Christina. Yes. You only use ides if it's like a monatomic ion. Thank you. Yay. All right. Okay, so
Spelling mistakes?
that's
Or?
barium.
Oh, barium.
And then this one, you put "ide" on the first word.
Oh my gosh.
And so if that's barium, then this is ionic.
I'm
Yeah.
so used to writing sulfide at the end.
Yeah.
Ah,
All right. John, okay. There you go. Lauren. So we have a metal and a non-metal, so no prefixes. Okay. And same thing for this one, actually. Metal, non-metal, no prefixes. But other than that, it's looking good. Okay. So for anyone who's not yet completed quiz 2, can you come in tomorrow during flex? Oh, and you're just finishing quiz 2? Yay! I'll give it to you. But I can't give you this one. This one is tetra. Yeah. Oh, there's some. I forgot that you weren't here for this when we first started doing these. So what we're doing is we're doing like little quizzes, and it's almost like self checkout. You go, there's quizzes like they're in a little tray at the back, and we pick them up, and when we're ready, we do it. Have you gotten the new book yet?
Yeah.
Yeah. Okay. Good. So if we're looking at that. I don't even know where my copy is.
Oh, like the.
Yeah, so it'll say like quiz 1. So once you've done that and you feel good about it, you can do quiz 1. And then once you've done the one that says quiz 2 and you feel good about it, you can do quiz 2. But if you have any questions about anything because you're away, definitely, come and see me. Watch the video, the one you missed. Yeah. Okay? Yeah.
Thank you.
Okay. Yeah. Just don't cheat. I know you won't. Bye.
When did you watch that?
That's okay.
Yeah. But our main one right now is we don't get how the ionization energy works of this. For example, like we were like chromium and lead. So like we were like, which one is bigger?
Oh, you don't need to worry about that for this test.
People were like curious.
Okay, for curious, yes, but you don't need to know it for this test. So go away. I'll teach it to you. Yeah. How do you know?
Which ionization energy?
I think it's going to be this one because it's got a lot less shells, and so this one, the electrons are a lot further from the nucleus.
But then there's more photons.
Yeah, but the R squared factor is R squared, not just. I believe the radius has more down and follow each other, right? You're not going to be like, one's over here and one's over there.
What are we, communist China?
Yeah. Yeah. I'll be like round to 2 decimal places or whatever. Hi. There's 3 of them that were actually wrong, number 4, 17, and 19. Yeah. So maybe those are. Yeah, so 17 is wrong, 19 is wrong. But we can still ask about the other ones if you want to. Okay. So those ones, you know what? Why don't I go over that as a class because I can't imagine if you're the only person with that question. Do you know what I mean? And so it's a good thing to ask. Yeah. Yeah. Probably, although I mean, when we look at this, we're looking at something that is pretty close to 39. Very little of it is anything else, right? You don't even have to really do much of a calculation. So if we've got 39.9, then which element is close to 39.9? And it's got to be that one. Nothing else is even close.
Bro, but aren't you supposed to include the, what do you call it? Quiz. It probably doesn't matter.
That makes no sense. Yeah. I'll ask around, but I can't imagine that that's not incorrect. Yeah. Hi.
So we got confused about ionization energy is basically for the valence. But that can be like for like running functions, right?
Hi. You know what? If you guys have individual questions, the first 5 minutes of class is not an awesome time. Flex time is an awesome time for individual questions. So I'm gonna send you all away. All right. What we can do is if you do have individual questions that you would like to ask while we're all talking as a class, that's fine. But this is like maybe towards the end of class, but I don't feel like the beginning of class is ideal. Otherwise, it's just a waste of time for everybody else, right? So. At the end of the day, I've like already taught for several hours, and I'm like, there's all this things happening, and it's very chaotic and confusing. I have no idea what you just said, but that's okay. Was it something to do with soccer? That's why I had no idea.